right, Richard, if you wouldn't mind, let's go ahead and kick things off a sec. Try not to get too dim. Yeah, obviously this is a little more comfortable than the previous venue, so I'm going to be counting heads here in just a minute. But, anyway, welcome to the April 2020 meeting of the Memphis Astronomical Society. 2022. Is that what year it is? Yeah, April of 2022. Yeah, the last time we met was March, and now it's April, so we're good, right? Obviously, there was a little bit of a hiatus. Having said that, not really sure what you'd say in a moment like this, other than welcome back, and yeah, we had a little bit of an interruption when it came to in-person meetings, but having said that, I am happy to say and very proud to say that the Memphis Astronomical Society has not missed a beat. So, yes, it's been a couple years since we've met in person. However, we have continued to meet. We just had to take a deviation and do it via Zoom. Some of you were active in that and saw some of our Zoom meetings. Others, they decided not to, but whatevs. So, but we're back, and to kind of kick things off, first of all, I do want to say thank you to Richard Townley and Dave Manis for allowing us to meet at the Planetarium. I would love to say that this is going to be an ongoing thing and we're going to be meeting here indefinitely, but the reality is I'm not sure. We're kind of taking this on a month-by-month basis. I would love to say we're going to be here indefinitely, but again, there's a lot of things that are outside of my control and our control. So we'll just kind of see how it goes, take it on a month-by-month basis. But we are very grateful to Richard and Dave for making this happen. Richard's in the back. Everybody say hello to Richard Townley. Hello. If you don't know Richard, he did serve on the MAS board for several years. Shortly after the pandemic hit, Richard fired his barber. And he's been looking for a replacement ever since. So if you know a good barber, please refer to Richard. I think we had an observing event here a couple months ago, and somebody came up to me and said, "Hey, did you see a homeless guy?" I said, "Yeah, no, that's Richard."
Jeremy, I was a part of the cue ball club for a few years, so.
Gotcha. Okay. Anyway, I like the new look. So, anyway, let's move forward here. We got a great program for you guys tonight. First in-person meeting in 2 years. We got 2 presentations for you. Here, one from Brian Hancock, somebody I've personally learned a lot from over the years. And then for those of you who want to stick around for the second half, I'll be giving you kind of a revised look at the Virgo Cluster presentation I did a few years ago. So, but to kick things off, again, we're the Memphis Astronomical Society, and we're a nonprofit public service organization promoting interest in education and astronomy and related sciences. Of course, you can find us on our website, memphisastro.org. Come on in. Sit down, don't be shy. And of course, we're on social media, so welcome once again. If you are not on our email list already and you would like to be, just simply click on the join button. And again, there's 2 places in the upper right. They'll take you to a separate form. You fill out your details, and we'll add you to our email distribution list. Pretty simple. Or you can go to the website joinmas.com also. So that's how you can get on our email list if you're not already on our list. Now, I do want to introduce some new members tonight. And we'll see, again, how we're going as we transition back into in-person meetings. So we've had a long-standing tradition of when we announce the new members, they typically are not here. But we got several of them. So if you are here, just raise your hand so we can acknowledge you. Paris Johnson. Oh, you are here. Paris. Everybody say hello to Paris Johnson. Welcome. All right, 1 for 1. Patrick Black. Are you in the house? All right, 1 for 2. James Holland Jr. 1 for 3. Joshua Hardy, are you in the house? 1 for 4. Phil Oaks. Oh, you see that, Phil? Let's say hello to Phil. Welcome to the Memphis Astronomical Society.
James Holland's on the Zoom meeting.
Oh, James is on the Zoom. Okay. Say hello to James. James, welcome. If you can hear us on Zoom, we're all clapping. I guess that's 3 for 5. And Chase Jackson, are you? Chase, welcome. Welcome to the Memphis Astronomical Society. All right. Outstanding. Fantastic. Well, that's pretty good. So welcome to our new members. We're happy to have you on board. And we have some information on the table out back, including star charts for April. If you haven't already, please take a moment to sign in the sign-in sheet out front. You can do that at the break, and we'll talk about that in a second. So anyway, obviously if you're a member, you get access to our newsletter, The Meteorite. Be sure you check out this edition. Not going to read the minutes tonight, but feel free, obviously, at any time to read the meeting minutes from the last Board of Directors meeting. If you have any comments or any feedback you'd like to give us, I mean, we're basically here to serve you, the membership, so be sure and check that out. Okay, so April 1 today. We got a busy month coming up. So let me just kind of go through this. Basically every weekend this month we've got something planned. So let's start. Let's kind of break this down. Now, tomorrow night is a regularly scheduled, we got two things going on tomorrow night. We've got Burton's Dark Sky Observing, and we've also got an event at Pinecrest. Now, this time of year, historically, we try to plan what's called a Messier Marathon. So, and basically there's 110 deep sky objects in the Messier catalog. Theoretically, you could knock them all out in one evening from dusk till dawn. We've tried to schedule that in the past, and every time we do it, it gets cloudy. So this year we didn't schedule it, and of course the weather looks great tomorrow night. So informally speaking, if you want to go for it, tomorrow night at Burton's would be a great opportunity, but it's just a regular dark sky observing session nonetheless. And we also have an event at Pinecrest Camp in Moscow, and the outreach team is going to be out there. I think we've got enough telescopes, but we can always use more. So if you want to bring your telescope out to Pinecrest, and the address is right there, and it's a little hard to read. It's in Moscow, Tennessee, basically just east of Collierville. And an indoor program, and then observing right after it gets dark. So feel free, if you want to come out, bring your telescope, and or just come out and participate in that event. So we got two observing events planned for you tomorrow night. Now, the following Friday, we are planning to do an outreach event for Germantown Parks at Bobby Lanier Farm Park. And I'm planning to bring my telescope out there. It's not going to be a formal presentation, basically just observing. But again, it's one of those situations where the more the merrier. So if you'd like to bring your telescope out, that's going to be next Friday, April the 8th at Bobby Lanier Farm Park, 2660 Cross Country Drive. Again, we'll send email notices out about this. The following Saturday, that's a week from tomorrow, we have an outreach event planned in New Albany, Mississippi. So if you got trouble at home and you need to get out on a Saturday night, this is a great opportunity for you. It's about an hour's drive from Memphis. I am planning to do this, any opportunity. So again, New Albany, Mississippi, we'll send notices out. But this is, again, just an observing and / outreach opportunity. Now, in a couple of weeks, the 23rd of April, we have our semi-annual Village Creek Star Party planned. And again, we try to do this twice a year, weather pending, in the spring and fall. And basically, Village Creek, again, is our major outreach activity. So we have an indoor presentation plan from 7 to 8, and then we always need telescopes for this event. We need low power, medium power, and high power telescopes. A lot of us, we meet in Forest City for supper around 5 o'clock, a little after 5 o'clock, and then meet up at the Visitor Center at 7 for the indoor program, and then at 8 o'clock is when the observing starts. So, and again, we send out notices about this, including documentation, and we give you detailed directions on how to get there, also the telescope lineup. So again, we're always looking for telescopes. We need a lot of scopes for this event. Low power, medium power, and high power scopes. Again, we'll send out email notices about this, but if you can participate in this outreach event, then definitely we'll take it. And we also have the observing guidelines. We've done this before. We did one last spring. It was or last fall. And it was a great opportunity. Had over 100 people come out. So again, Village Creek, it's about an hour's drive due west along I-40. Get off at exit 242, that's Forest City. Meet at Delta Q for dinner about 5:30. up to the visitor center near Wynn, Arkansas, about 7 o'clock, and then telescope operators set up, and observing goes from about 8 until 10 o'clock. So April the 23rd, again, we will send notices out, including the go/no-go, depending on the weather, but kind of tentatively be thinking about that. And then the following Saturday, April the 30th, last day of April, we'll have another dark sky observing session planned at Burton's Sugar Farm. So anyway, every weekend this month in April, weather pending. Yes, Ann?
You forgot, next Friday, we're observing here at MoSH on the lawn.
Oh, thank you. Okay, so next Friday, April the 8th, in addition to Germantown Parks, we also have an observing and outreach event right here at the MoSH Planetarium, or out front in the lawn. So we did this, was it last January, I believe? So we've got another one planned, and we need telescopes for that event as well. So that's April the 8th, next Friday. So you can come right back here, bring your telescope, and again, we're trying to improve our relations, if you will, with the MoSH Planetarium, and there are some benefits, there is some upside, such as the opportunity to meet here. So yeah, take your telescope out next Friday, April the 8th, to the MoSH Planetarium for that outreach event. Did I miss anything else? Okay, so that pretty much covers April. So we've got 2 things going tomorrow night, we've got 2 things next Friday, and then next Saturday we've got something. So every weekend we've got at least 2 or 3 activities planned. So again, we'll send out email notices about this as we go. Okay, speaking of outreach, I just want to highlight a couple things that happened within the last month or so. So the Cub Scouts, this was Ann and Rebecca, who are both members of the outreach team. Now it looks like the observing part of this was clouded out, but they did meet with the kids and gave them presentations on astronomy. There was a write-up from Rebecca. We'll feature that in a future edition of the Meteorite. But this was a great opportunity, again, to more or less teach and network with kids on astronomy. So this happened earlier this month. And then also we did an event at Pinson Mounds. And this is one that we did a couple weeks ago, just after the snow, the late March snowstorm, if you remember. Pinson Mounds is about an 1.5-hour drive from Memphis, just south of Jackson. It's an archaeological site. And it's really a great place for astronomy. They got mounds there, got a wide open field, pretty decent dark skies, and a great venue for presenting. So we have a new telescope now called Stellina. It's a robotically operated telescope that is basically turnkey. You push a button and it slews to a target, and then you can display it on a screen. So we've been playing with that. Rick and Merrill brought it out, and so we did an indoor program, and then also had live feeds of the objects inside of the observing room. But then people who attended also wanted to go outside and freeze and then look through the eyepieces of our telescope. So got a little bit of both, but it was a great activity, great event, and they want us back. So that's always good. Okay, and of course for outreach, we do have a page on our website. If you would like to request the services of the MAS, you can always go and click on the form in the upper right there. And again, it'll bring up an outreach form. You just fill it out, give us your details, and then we'd be happy to schedule something for you at a time that is convenient for both of us. So yeah, let us know if you'd like to request the services of the Memphis Astronomical Society. And with that, do we have an astrophotography meeting planned this month? I'll let Rick.
Yeah.
Yeah. Okay. So look for notices regarding this. Again, it'll be a couple weeks from now. Usually we do it every month around the full moon, and it's fairly informal. It's done via Zoom. But if you'd like to learn more about astrophotography, or if you have questions or things you want to share, it's basically an open networking opportunity. So that would be April the 16th, 2 weeks from tomorrow. Again, right around the time of the full moon, and we'll send out.
This is a learners and teachers event, right? We don't do presentations like we do here. This is get on there and ask questions. People may have something they want to show. Just open open mic kind of thing, all
Right.
done on Zoom.
Teachers and learners, match them up so you get some mentoring, and again, very, very open-ended, but
We got
there's
some really good
discussions in this
teachers
group.
too,
Yeah.
and some excellent learners.
Excellent learners. Absolutely.
And a couple of dummies.
So, if you're interested in learning more or getting more involved in astrophotography as a teacher or a learner, this is a great opportunity. All right, and with that, I'm going to go ahead and turn the show over to our first presenter. We got, again, 2 programs. Yes?
I have a comment. I just think it's time to thank you and compliment you and Rick and everybody that was responsible for the 24, or close to 24 programs you put on over the last 2 years by Zoom. They were phenomenal.
Thank you. Yeah, a lot of people stepped up over the last couple of years. Not only board members who served, but individuals volunteering to take their telescopes out and participate in outreach events, presentations for outreach events. I mean, there are a lot of people that really stepped up over the last 2 years to keep the train rolling, so to speak, during a period of uncertainty. So I appreciate the comment. And again, 2 years ago, we weren't sure. Shut down for a month, let's see what happens. Maybe we'll get back to,
But the programs were great, and I mean, being able to bring in Vandy and some of the other locations by Zoom, it was super.
yeah, we really capitalized on this unique opportunity. Last month, some of you saw we had Gary M. from Onalaska, Texas, who gave a presentation on photographing the ARC catalog of galaxies. A year ago, we had Tom Calderwood, who wrote the cover article for Sky and Telescope magazine on the great dimming of Betelgeuse. We also had some great local presenters. We had Dr. Francisco Mueller-Sanchez, who's a professor at the University of Memphis, who's got telescope time reserved on the James Webb. We got involved in virtual star parties with other groups throughout the state of Tennessee, so we're starting to get involved in that as well. I didn't post our numbers, but in terms of our outreach and subscriber base, that really went up quite a bit in the last couple of years. Again, all as a result of basically being forced to do this virtually and really capitalize on technology. So it was a unique set of circumstances. And it was a moment of crisis, but as the ancient Chinese say, that the equation for crisis is equal to risk plus opportunity. And I'm very happy to say that in terms of the opportunity side of that equation, I think we really capitalized on it. So, and it was, again, the result of numerous people who stepped up and volunteered their time. Many of them are in this room: Rebecca, Ann, Rick. These are all very busy people. Richard, Brian, I mean, I can name them all. People who served on the board, people who are not serving on the board. Mylan, he rarely comes to a meeting, but he always takes his telescope out to our outreach events. So, yeah, one person can't do this. It's impossible. Really, I'm just along for the ride. So, to everyone who has volunteered their time, you don't get paid for this. And people, you know, again, we're busy, we have lives, we're professionals.
I don't
so
get paid.
You don't, believe it or not, yeah.
They're all a bunch of addicts.
We're just here to share our passion for astronomy. So, with that, I'm going to go ahead and introduce our first presenter tonight. And this is, again, is an individual that I personally have learned a lot from over the years at outreach and observing events. And one object in the night sky kind of stands out from all the others, and that is the moon. And we got to deal with it every month, for better or for worse. But it turns out that there's an entire catalog of craters on the surface of the moon that could really help you in your outreach endeavors. It's something I certainly need to learn more about. And that way you don't just show people the moon through a telescope, but you can actually point out specific features. So with that, I'm going to go ahead and turn the presentation over to Mr. Brian Hancock. Brian, the floor is yours.
Everything's working. Well, since I'm the second best looking bald guy, I'm going to keep my hat on. So welcome to the introduction to the Riccioli catalog of craters, and I want to start off with a softball question, and I'd like to address the young people in the room. Can you name for me which crater on the moon, and it's not the brightest, It's not the largest, but it's the most conspicuous crater from our vantage point. It's got the largest ray system. Does anyone know what that crater is?
Tycho.
Tycho, yes. You say Tycho, I say Tycho, but young people, you should have learned pronunciation from me. When I was a kid, I always said that I wanted to go to Yosemite National Park in California. And it wasn't until I went to college that I learned the proper pronunciation of Yosemite. So don't learn pronunciation from me, kids. Yes, Tycho. Tycho crater is the most conspicuous crater from our vantage point. Let me ask you another really easy question. And just for fun, just indulge me, a show of hands. Who has looked at Tycho crater through their telescope? Everyone, right? Everyone from Yosemite to Mississippi has seen Tycho crater through the telescope. Kids, I want to ask you another question. Can you name for me the Italian scientist who's known as the father of physics? He's famous for dropping things off of the Tower of Pisa. Does anybody know? Galileo. Galileo. Let me ask you this. Who has looked at the crater named after Galileo through their telescope? Anybody? The crater named after Galileo is called Galilei. Okay, yes, we do have someone who's seen that. What is going on here? Why is it that Tycho crater is such a conspicuous crater, and Galileo, the crater named after Galileo, is this little bitty guy? It doesn't seem right. It seems like a travesty. What we're going to look at tonight is going to try to explain this mystery. We're going to look at why Tycho has stole the show. Now, I came about this presentation because to me, I didn't understand how the craters got their names. It made no sense to me. It made about as much sense as a dart game where all of the scientists of the past were lined up and they threw darts at the moon, and wherever the dart landed, then that part of the moon was named after them. On one part of the moon you have a Catholic Pope in the 4th century, and he's got a crater. And then somewhere else on the moon you've got a Greek philosopher. And then on another place on the moon, you've got a medieval scientist. It didn't make any sense to me until I came across this guy. The IAU, they are the ones who approve names for craters. And not just craters on the moon, but craters throughout the whole solar system. Right now, there are over 1,500 approved names for lunar craters. Giovanni Riccioli, he proposed 247 crater names, and 187 of them stuck. Now, the reason that is so important, it doesn't seem like a lot, only 187, but he chose the best real estate. The most conspicuous, biggest craters, the ones that you see when you look through your telescope, they were named by this guy. So it'll help us to know something about Riccioli, to know something about how he came up with his nomenclature. Sorry about that. There we go. So we're going to have a presentation in 4 parts. The first thing we're going to look at is lunar cartography up to the time of the New Almagest. What is the New Almagest? That is Riccioli's masterpiece. Now, everybody's heard of the Almagest, right? You haven't heard of the Almagest? There was a scientist, his name was Ptolemy, and he wrote a book called the Almagest, and it was the encyclopedia of astronomy. Riccioli wanted to be the new Ptolemy, and he wrote a book called The New Almagest. And in The New Almagest, he sets out his lunar nomenclature. So the first thing we're going to look at is what led up to The New Almagest. We're going to address who is Giovanni Battista Riccioli. We're going to look at the secrets of his map. And finally, we're going to look at some examples from his lunar crater catalog. So starting from the beginning, way back, what is if you look at the moon, what is the most famous thing that you see on the moon, just naked eye? It's the man on the moon, right? That is an example of, here's another pronunciation thing. Throughout this presentation, you will hear me say Maria. I'm sorry, I know it's Maria, but I can't help it. I'll say Maria. If I say Maria, just roll your eyes and ignore me. When we're looking at Marium and Pareidolia, this is how the beginning of lunar maps occurred. People looked at the moon, they saw the Maria, and it looked like something, right? It looked like the face of a man, or it looked like a rabbit. And that's how they started drawing maps of the moon. Plutarch looked at the moon, and what he saw was an entrance. And through this entrance, that's where the souls of people went when they died. Shakespeare saw something else when he looked at the Maria. Shakespeare, in A Midsummer's Night's Dream, he said, well, this looks like a guy here. And here's a little dog. And here's a bush of thorn. So first we started off with just seeing things on the moon. And then eventually people wanted to start naming the features. That's where we get the nomenclature from. The first guy to actually start naming things, he made a big mistake. He didn't publish. He didn't publish until 1651. And what happens when you're not the first? People pass you up and your names just go into the void. The second guy, Thomas Harriot, he made the first known telescopic sketch of the moon. He beat Galileo by, I think, 3 months. Galileo, we already know, he published sketches and detailed descriptions of the lunar surface. And what Galileo is famous for is really blowing up Tycho crater, right? When you look at Galileo's sketch of the moon, Tycho crater is huge. And his reason for doing that is he wanted to show, hey, look, the moon is not perfect. He was trying to exaggerate the features of the moon to show what was there. And finally, we have a very interesting guy, Pierre Gassendi. Gassendi had a very interesting nomenclature that, again, unfortunately, he didn't publish it. And I really wish he had it, because his nomenclature was really interesting. I find most interesting the name for Tycho, umbilicus lunaris, the belly button of the moon. And the first time I showed my wife the moon through the telescope and she looked at Tycho crater, that's exactly what she said. She said, it looks like the moon's belly button. He has a lot of interesting names that you can only find in Gassendi's diary. He wanted to publish a full nomenclature for the moon, and time ran out, he got sidetracked, and he never published it. Now we come to the big three. These three, they started with maps and with names for the craters. and for the Maria. First, sorry about that.
You need to go back.
Trying to get used to this, yeah. There we go. The first was Van Langren. Now, Van Langren had a very interesting motivation. He wanted to try to find a way to pinpoint longitude on a map. And if you look at Sky and Telescope magazine when there's a lunar eclipse, you will see that they will publish times for when the shadow goes across the crater. But those times are specific to certain areas of the country. So if you're on the East Coast, it'll happen at a different time than if you're in Colorado, and that'll happen at a different time than if you're in California. And that can help pinpoint your position on Earth. Van Langren was in the service of the Spanish monarchy, and they really wanted Van Langren to succeed with this endeavor so that he could help the Spanish Navy. So he came up with a nomenclature that was totally named after royalty. Imagine a Trump crater, and then a Biden crater. That was his nomenclature. So you can see for Mare Crisium, Mare Caspium, that's not too bad. But for Tycho crater, try to roll this off your tongue. Vladislav IV. That's what he called Tycho crater. Vladislav IV was the king of Poland. The other interesting thing about Van Langren is he tried to call dibs on the moon. Basically, he said, look, I've come up with this map. I've got this nomenclature. Now, nobody else can do it. And if you do it, there will be a fine of, $5 or $10. Next came Hevelius, who obviously ignored Van Langren's warning. Hevelius was the mayor of a city in the Kingdom of Poland. He published his map in 1647, and his map was considered much better than Van Langren's, except he used a very odd nomenclature where he named everything on the moon after geography on Earth. So there are no personal names at all. Everything, so there's a Memphis, Tennessee, there's a Memphis on the moon. That's how everything is named on his map. And most scientists kind of found that clumsy. His names were difficult to pronounce, even for Latin speakers. And finally, we come to our man, Riccioli. Riccioli was a Jesuit theologian and astronomer. We already know he published Almagestum Novum in 1651 with a moon map, and his moon map caught on. His moon map caught on. He named his craters after famous scientists in the past. He didn't name them after royalty. And the other scientists began to use his names, and that's why we have the moon map we have today. This is, again, Van Langren's, and just look at Van Langren's title for his moon map. Lumina Austriaca Philippica. So he's naming it after King Philip. That's going to be his moon map. Then you have Hevelius's. Sorry for the echo. With Hevelius's, he starts to show the libration. Oh, there we go again.
Oh, sorry. Do you need me to go back?
Yeah. Hevelius begins to show the libration in the moon. But again, his map was very clumsy. His nomenclature was very hard to learn. And finally, we have Riccioli's map. He borrows from Hevelius the idea of showing the librations of the moon. And now we can begin to see the moon that we're familiar with. We have Mare Tranquillitatis, right? where some of the Apollo programs landed. We have Mare Crisium there. We have the Sea of Storms there. And eventually I'll stop doing that. But this is the map that we're more familiar with. So Riccioli, who was Riccioli, and how are we to evaluate him? So there's a secret on this map. So again, we're trying to understand why is Tycho crater so much bigger than Galileo's crater. There is a lot of speculation that Riccioli was a closet Copernican. That as a Jesuit priest, he couldn't openly say, hey, I believe the earth revolves around the sun and not the sun around the earth. He had to kind of give little hints, and he put those hints in his map. And some people say, no, you know, he really believed the sun went around the earth, and he was just too closed-minded of a theologian to figure it out. We're going to look at the evidence and try to figure out which one of these is true or if something else. So one of the best definitions for Riccioli is he was the last great apologist for the geoheliocentric model. He was one of the last great ones who argued that the sun revolved around the earth after Galileo. With his Almagestum Novum, it's a 1,500-page encyclopedic work, and it's got tons of information in it. It's not just about the moon. The moon is only one chapter. He did a lot of experiments with pendulums and falling bodies. He really found Galileo annoying. And Galileo's experiments with pendulums and falling bodies bothered him. And he wanted to duplicate those experiments. And we'll talk a little bit about that in the next slide. He had 126 arguments concerning the motion of the Earth. The most important of those are the star size problem, the Coriolis effect, and the lack of observed parallax. So what is the star size problem? If you look through a telescope, you'll see the star, especially telescopes at that time, do not look like a point of light. They look like a disk. At that time, they did not understand that that was a false image, that that was a spurious light rays. We call that now an airy disk. They thought that that disk represented the true size of the star. So here's the problem. With the Copernican model, with the stars being outside the orbit of Saturn and being so far away, that means the stars had to be huge if they were that far away. With the Tychonic model, you didn't have this problem. So this was his first big criticism that he never got over, was the star size problem. The Coriolis effect, he also did a lot of writing about this. The Coriolis effect is, you think about this, the Earth is a globe, right? On the equator, it's actually moving quicker, it's making a bigger circle than at the poles, at the North and South Pole. So this is what Riccioli said. He said, look, if the Earth were moving, let's say I take a cannon at the equator and I shoot it at the North Pole. It's going to be deflected. It's not going to land where it's supposed to because the Earth has been moving, right? That's the Coriolis effect. And he said, but look, you know, people who are really good at shooting cannons at each other, they can even shoot a cannon into another cannon. They never see this effect. Now, at that time, they didn't even call it the Coriolis effect. And Riccioli was correct that this should occur, but it occurs on large scales. It doesn't occur on the small scales that he was thinking about. And finally, the lack of observed parallax. Again, this is something that does happen and that you can measure, but it was impossible for them to measure at that time. So what is parallax? Just hold your finger out and shut one eye and shut the other one. It looks like your finger's moving, right? So as the Earth moves around the sun, if that theory is correct, as the Earth moves around the sun, you should see the stars shift back and forth. And Riccioli says, we don't see that, so the Earth can't be moving. Those three arguments were the most important for him. And then finally, the lunar nomenclature was in his book. So going back to the falling body experiments that he did, he's famous for, at the Asinelli Tower in Bologna, that he actually ended up verifying Galileo's theories. This is one of the most incredible things that he did. Galileo was, didn't have good things to say about Galileo. He thought Galileo was deceptive. And after he performed these experiments, he actually made the first accurate measurement for G. So he, based on the data in his Almagestum Novum, he measured G to 9.36 plus or minus 0.22 meters per square second. Now, to be clear, he didn't say, I've measured G and this is what it is. The scholar at the Vatican, Professor Graney, Riccioli has data in Almagestum Novum, and he records the rate that everything fell. And if you plug in the data, you come up with that number. So again, let's go back to this map, and let's specifically address why Tycho is so big and Galileo is so small. If we look at the secrets, of this map, you'll see that it's divided into 8 octaves, going clockwise around the moon. There we go. So if you go clockwise, around that map, you will make a discovery that the craters are not randomly placed. In Octants 1, you will find most of the, Octants 1 and 2 actually, you will find most of the ancient Greek philosophers and scientists. And next time you're observing the moon, go to that area. You will see Pythagoras, Xenophanes, Eratosthenes, Aristoteles, Plato, and Archimedes. You'll see that they're all in those 2 sections. Keep going clockwise to Octants 3. You start getting into Hercules, Atlas, and Endymion. What's interesting about Riccioli, which we'll look at later, is, of course, was Hercules a real person? No. What about Atlas? What do you think?
Not so much.
Yeah. Riccioli says they were real people. And we'll look at what his biographical, he's got a chronology, and we'll look at his ideas about Hercules and Atlas. Keep going clockwise, and you'll come to Octants 4, and you start getting Seneca, the Stoic philosopher, Plutarch, Julius Caesar, Sigismund. Keep going down, and you're going forward in time, and then you get the Theophilus. He was a pope in Alexandria. Petavius and Piccolomini, a 4th century pope. Keep going, now you get to Albatignius, Arzakel, and Tycho. Octant 7, Schiller, Gassendi, and Schickard. And finally, in Octants 8, and this is the most important octants for our discussion, you get Copernicus, Kepler, and Hevelius. So the first thing we see, the first secret we see with this map is that the craters are not randomly placed. If you follow this in a clockwise motion, you will see this logic. Secondly, now let me point out, I do not know Latin, so why am I throwing Latin up here? I'm throwing Latin up here because I don't know Latin. If you've ever taken some medieval Latin and throw it into Google Translate, you will get some really crazy translations. But Latin does have a lot of cognates with English, and a lot of times you can look at it and just get an idea of what it's talking about. And maybe some of you know Latin, so it's better I just show you the Latin instead of doing something that distorts it. What we can see right here is another secret to his map is he says, I didn't casually, something like that, or randomly distribute the names on the disk of the moon. What he tells us is that all the buddies are grouped together. So for Copernicus, we have Rheticus. They're together. For Plato, we have Timaeus. They're together. And he's not too far from Aristotle. They're together. So that's another secret for you. When you're looking at the moon, you're going to see that a lot of the scientists who work together, they're going to be together. The craters are going to be together. Finally, the biggest thing that he says is all of those Copernicans, Rheticus, Reinhold, all of those, the people of that sect, I threw them in the ocean of storms to float as islands. And why did I do that? Because they said the earth moves. The earth is unstable. So we know now that Oceanus Procellarum, the ocean of storms, why are all of the people who were of the heliocentric persuasion, why are they on that side of the moon? You know, on the other side of the moon, you have some really nice real estate, right? You have Mare Tranquillitatis. That sounds like a nice place to be. Or you have Mare Serenitatis. But over here in the ocean of storms, Riccioli says, I threw those guys over there because of what they believe. So what we want to address is, did Riccioli secretly support heliocentrism? And a lot of authors have put this forward. This guy says, hey, inwardly he believed the Copernican system was the correct one. Now, what is his reasoning for that? Because we've already established that Tycho is the most conspicuous crater with the largest ray system. But what's number two?
Copernicus.
Copernicus. So he gives Copernicus a pretty good crater. He treats Copernicus much better than he treats Galileo. So a lot of guys say, look, it's telling. He gave Aristarchus. Aristarchus is the brightest area of the moon. Aristarchus, Copernicus. He gave these guys, you know, pretty good real estate. So maybe that's kind of giving a hint of what his true leanings are. And finally, this guy concurs with him. I don't believe that's true. I believe that we can take Riccioli at his word, and I'll tell you why. There is a frontispiece to his Almagestum Novum, and in this frontispiece, the picture basically tells the same story of what he's already told you. He's already told you in his map how he feels. He's told you in the text how he feels. Now he tells you in this picture. In this picture, we can see, first we see the system of Ptolemy, and it's on the ground. And here's Ptolemy right here, and you can't see the Latin text, but the text says, "My bad." Yeah, that's basically what the text said. Here you have, this is the muse of astronomy, uranium. And this is the all-seeing Argos. And they're weighing the Tychonic system, and the Copernican system to see which one is weightier, which one carries more weight, and which one wins, the Tychonic system. So he's telling you the same thing that he told you in the map. He thinks that Copernicus, mathematically, is a very good system. So he gives him the second best crater. He thinks it's better than Ptolemy. Ptolemy's on the ground. So he's being consistent in what he's telling us. Secondly, if you look at Octans 8, again, here's Copernicus, here's Oceanus Procellarum, the ocean of storms, here's Keplerus. They're all in the ocean of storms. A lot of people say, but hey, look, where is Riccioli? He's right here, Ricciolus. So they also say that is another little hint. You know, how come he's not hanging out with Tycho? How come he doesn't put his crater by Tycho? How come he puts his crater over here with these guys? Again, the point to look at is, but where are they located? Out of the ocean of storms. They're not in the ocean of storms. And again, it was common for the map makers that just started, Van Langren, Hevelius, to name a crater after themselves, but they would put it at the edge of the map. It's kind of like a painter signing his painting. He doesn't sign it right in the middle, right? There's somewhere off on the edge he signs the painting. So the point with this is, it's not the Octans 8 that's important. It's being in the ocean of storms that's important. So the last thing we're going to look at is I'm going to give you some examples of the crater catalog by Riccioli. You can download this catalog. I believe it's on the website now. If you go to the website and you go to the bottom of the description about this talk, there's a PDF file that you can download and you can get a copy of this catalog. What you will see in the catalog is we will name the crater, the eponym, and the date. That's because sometimes the name that you know, like maybe Aristotle, the name of the crater has been Latinized, so it's going to be Aristoteles. Then we'll try to look at some ideas and contributions of the person that the crater is named after. What I've tried to do as much as possible, and sometimes it's not possible, is I've tried to give you a direct quote from the person. And with some writers, that's very easy. For example, Galileo. You can go through his books and pull out a quote. For others, it's very difficult. And an example, actually, Riccioli is difficult because all of his writings are in Latin. They haven't been translated into English. But another person that's difficult, Thales, Pythagoras, Xenophanes. These ancient Greek thinkers, usually the only way we know that the pre-Socratics, what they thought or what they said, is Aristotle told us what they thought or what they said. So the second best thing that I try to give you is if I can't give you a direct quote, I try to give you a quote from someone who is also in the catalog. so that it's self-referential. And then finally, you'll notice in the catalog that there is some detail about the crater. Maybe I'll talk about the shadow play, maybe about the best day for you to observe that crater, etc. And in the catalog, you'll see LC a lot. LC refers to Luna Cognita. It's a 3-volume book. You will see hyperlinks in the catalog. The hyperlink, if I give you a direct quote, there will be a hyperlink that you can click on and it'll take you to the source. You can see where I got the quote from. And if you see images with no credits, it's because they're in the public domain. It's maybe from the Lunar Reconnaissance Orbiter, or someone who has just put it on Wikipedia in the public domain, and they waive their rights. If you do download the catalog, please feel free to modify it, to share it, to add to it as you like. Consider this an invitation. There may be some thinkers that you are interested in and you would like to add to the material that I have on it. I'd be more than happy. So let's look at a couple examples. And also you will see for the crater detail, a lot of times you will see the age for the crater. And this cheat sheet will let you know, for example, a Copernican crater is going to be a younger crater, and a Copernican crater is going to be more likely to have an extensive ray system. Whereas you will see some craters, especially Nectarian craters, they will be highly degraded. And some of them may be barely visible because of it, they've been filled in with lava. So here's an example. I told you we would come back to Hercules. So Riccioli says Hercules was an astronomer in 1560 BC. And again, there's the Latin, and it kind of gives you that, he seems to imply that he succeeded Atlas as an astronomer. And so Riccioli seemed to think that the myths that we know, that was one of the 12 labors of Hercules, that he had to hold up the sky for Atlas for a bit. He seems to think that they have some real historical value to them. Also, we've got a Seneca is one of the craters in the Riccioli catalog. So again, I've given you something that's self-referential in the catalog, giving you a quote from Seneca. And then finally, you can look at the crater, give you a picture, and give you a short description. It has terraced walls. And you can notice a Copernican age cone crater in the crater, on the crater floor of Hercules. I give you the diameter and the best day to look at this crater. Unfortunately, with Riccioli's system, by having the map in octants, octants 1, 2, 3, 4, 5, 6, 7, 8, that's not a very convenient way to observe the moon. The best way to observe the moon is during a lunation. You look at the crescent moon, and you look at all of the craters that are along the terminator. So I've given you the best day to look at these. It's, like I said, it's very difficult to follow it by the octants. And let's look at one more example. We can skip that because I was afraid you wouldn't be able to see it in detail. Going back to Galileo, Reiner Gamma. Now, we need to cut Riccioli a little bit of slack because at the very beginning of the talk, I showed you that crater that is named after Galileo, and Riccioli didn't do that. He's not responsible for that. A later scientist named Madler actually moved Galileo to that crater. Riccioli initially named Reiner Gamma as Galileo's crater. And this is actually a much more interesting formation on the moon. Reiner Gamma is something called a lunar swirl. And scientists aren't exactly sure what caused it. And there's even speculation that it's the remains of a comet. It has its own magnetic field. And so it's a really interesting object. And it's kind of appropriate that Riccioli was, you know, maybe he didn't have the best feelings toward Galileo, but he ended up giving Galileo a really interesting feature on the moon. So I actually refuse to acknowledge that Galileo's crater is what Maitler says it is. I still consider this what Galileo's place should be. And there's a quote for you from Galileo. Again, I can skip this, I was afraid. And we've come to the conclusion, and I want to, again, go back to the beginning and talk about Plutarch. One of Plutarch's ideas that he discussed in his book was there was an ancient belief that the moon was like a mirror. In fact, if you wanted to see the Great Sea on Earth, you couldn't see it, right? How could you see the Great Sea? Look at the moon. The moon is reflecting back what the Earth is. So if we want to know Earth's geography, we can just look at the moon. This was an ancient belief. Of course it's wrong. Sorry, I still can't get the hang of the clicker. There we go. But one last quote from Riccioli, and thinking about the moon being a mirror. Riccioli said, humans don't live on the moon, and souls don't go there when they die. Now, the 3 points I want to bring up with looking at Riccioli's work and the shadow of Galileo that hung over it was that we live in a very similar time. Now, I'm not trying to say that it's exactly the same, but during that time, they struggled with what was heresy, what was truth, who should be censored, who should be allowed to speak. And my only point is, things haven't changed. We're struggling with the same thing today. You know, what is misinformation? What is disinformation? What is truth? Who should be censored? We have the same struggles today. Was Riccioli too much of a theologian or a closet Copernican? I don't think either one. I honestly think Riccioli was just a guy doing science the best that he knew how. And he was wrong about some things. And about other things, he actually progressed science with his experiments on falling bodies. So the second point I'd like to make is science is a multi-generational effort. You can't just look at the Einsteins and the Newtons. You've got to look who led up to them. We need the Ricciolis just like we need the Galileos. And then finally, it's a very interesting point of irony that I believe his name is Andrew Livingston. He wrote an article in Sky and Telescope. He said it's very, very ironic that Riccioli said that souls don't go to the moon when they die. And then he creates this very intricate map, and he memorializes all of these great thinkers and scientists on the moon. And now they live there. So that's the conclusion of my talk. I'll be glad to take any questions unless I can't answer them.
Thank you. Richard, look at the lights.
A little more light.
Yeah. And Dan.
Yeah.
You had mentioned the younger craters were the cone-shaped ones that hadn't really been filled in, kind of like the Earth.
Yeah, sorry.
You had mentioned that younger craters were the more cone-shaped craters, visible that hadn't really been filled in, like the Copernican crater. Do we know kind of the age of some of the youngest craters that you're referencing?
Right. So so they're less than 1 billion years old. I think they could be over 1 billion, but around 1 billion years old. But the cone crater is just from a smaller impact. So a complex crater like Copernicus. So
Multiple impacts.
well, it's a huge impact. What happens is you get a huge impact, and we say it's a complex crater because it makes an impact. The floor goes down, and then it fills in, and that creates the central peak complex.
Okay.
So it's the size of the impactor that would create either a cone crater or a Copernican-aged crater. And the younger the crater, you're going to see a ray system. And just what happens, erosion over time, due to solar radiation, or from other impacts, then you'll lose those rays, you'll lose the walls, and that's why the older craters will look filled in like that.
Is that why scientists were so excited about the Chinese satellite crashing into the moon so that they could study that impact?
That I don't know. Jeremy, do you know?
The rocket. Chinese moon rocket. It is a rocket that crashed on the moon recently. They first said that it was a SpaceX rocket. And then was determined that it was a Chinese rocket. And they were so excited because they were going to be able to measure again vibrations and the impact on how the crater will affect the seismographers inside around the moon.
Oh, okay. Yeah, I don't know anything about that, sorry.
Well, I know they've intentionally crashed rockets into the surface of the moon to measure the water content in some of the bases of the craters.
They weren't measuring it, they were looking for it.
They were looking for it, not measuring it.
One of the satellites that mapped the moon, when it finally ended its mission, they knew that there was a crater on the south pole whose the bottom of the crater had never seen sunlight.
Yeah.
So they were hoping that there might be some hint of water ice at the bottom of that crater, and they crashed the satellite into it. They asked for amateurs and everybody that could to get out and record the event, and me and some other people went over. We had to go over to Oklahoma to be in the right place at the right time, and we recorded it all and set up all night, did all this stuff, and didn't see a thing. And when we were driving back to Memphis that morning, the next morning, we stopped at a gas station. Scott Dagenhart and I did this. And there was a news article on the TV in the gas station about the Hubble Space Telescope. Had been watching this thing, and it didn't see anything either, so I didn't feel so bad.
Keep looking.
I'm sorry, I don't know if that answers your question. Okay.
Anybody have any other questions? Rick, how about from our Zoom audience?
Any questions, James? You can type them in the chat. I think we're good.
We're good. Great. Thanks,
Do we have
everybody.
anybody on Zoom? Oh. Another applause for Brian. Get in the back. Okay, we're going to take about a 5-minute break because we got to get set up for the second half of the talk. Restrooms are around the corner, of course. If you haven't already, please sign in at the table out front. There's some other stuff. There's pens. There's magnets. There's postcards we're trying to get rid of. So please do us a favor and take that off our hands. And we have star charts as well. We'll be back here in about 5 minutes.
Hot mic here.
Oh, mine's still on.
Oh, now. Great. Now it's now. Okay.
Great job, Jeremy.
Boy, that's, you researched the heck out of that.
Yeah, it is a lot of work.
Talk about schools?
No. Yeah. No, I had an embarrassing moment at an outreach event when I was showing someone the moon, and a young kid asked me to tell him more about it, and I couldn't say a thing. And I was so embarrassed that I said, I'm not going to let that happen again.
And how many years ago was that?
It wasn't too long ago. It was one of the...
What you said about the Jesuits, I had 6 years of them. There ain't a word.
Sorry about that. Well, I'm not Catholic, so I wouldn't know.
There, I don't like the one we got right now. He's a communist. Yes, I am Catholic.
Okay.
Cradle Catholic.
Oh,
You ever see the Atlas of the Moon?
That's probably.
Yeah.
You got the hardbind.
Right. Yeah. I love those.
Back in my younger days, when I wasn't observing girls.
Gotta take off. Great job.
Oh,
Hope to
yeah.
see you again.
Yeah, I've kind of gotten addicted to it because it's so easy.
But you
know, I spent so much time obsessing and trying to get to the dark side.
But I mean,
light pollution and whatnot. And you can just have a telescope right by the door, grab it, walk outside, observe for 10 or 15 minutes, and
maybe you got to tell them.
go back inside and that's it.
Somehow or other,
Yeah, you have to know exactly when to look for.
Another one that I did
supposedly, I don't know if it's true or not. Supposedly,
I can get sales, but I can't get tips.
Right.
Everything is
electronic. I need to upgrade mine too. We had a similar problem. Recording the call. Rick has the professional version. That's what we're probably using.
Well, I think that's when I was paying $16 a month.
Are they still?
Well, no, not that one, but I was on the other one. So I wanted to get rid of that and just go back to what I had. But I'm not sure if somebody can help me, and they have to connect with that.
That's hard to get a hold of.
Yeah. Oh, well, what I'm going to do Monday, I think it's called sales, and say, okay, give me an Right. Because it's a handy device. I mean, look at what.
And of course, there's the lunar 100 that Charles Wood put together. That's a really interesting.
I already observed everything that's on the sky telescope.
To be back.
Atlas of the Moon, lunar moon map. So I did that when I was 14.
Still interested in it.
I was really active back then.
Well, I
didn't have any girlfriends, but
it's usually, I mean, not always, but astronomy club is always the best place to make breaks.
Yeah, it's heartwarming to see the.
I was in Pittsburgh. We had a hotel. We had some dark skies down on the south side.
It's a great ride.
Absolutely.
Always good to see you, Bill. Sorry.
See you later, Jeremy.
Take care.
Say hi to
One of the
Sarah.
better known officers in the AAVSO was George Newell. Pittsburgh. He helped me, coached me, got me authorized to submit. I submitted 500 some observations. I got a little certificate for it somewhere home in the attic. But been at this for 65 years.
You held your back there when you said that.
Well, I got my first telescope when I was 9 years old, and that was 1956. So on October 4th, 1956, I became the most popular kid in school because I had a telescope.
Thank you.
Yeah, the case is not metal like the A's are. I would go outside the house and see how I can connect.
It's gonna be a long day tomorrow.
We started.
It's PD day for accepted students. It's our last chance to get them to they're positive that they've been accepted, so they're still
I was so excited. People said like I've never seen you so excited for such a long time.
presentations in the morning on why you should come to Rose and sit into this free and show. But then this thing's tomorrow night too.
Are you doing that?
Oh, that's not exciting. What we just did?
Yeah, stars.
Yeah. Very cool. Good. Did you learn about the moon? Yeah, I've never looked close. I mean, I looked at the moon. It was pretty crater, but I've never really thought about how they were named or anything. So I was just looking at my moon map, going, "Oh yeah, there's that one and that one." Yeah, it's like a piece of pie, right?
I still don't like it. It would have been better to do it very faces.
Kind of an odd place for your work.
Yeah, that would make more sense. But it's kind of interesting.
It was interesting.
It's a cool
It's worth it for a day.
But I kind of wonder if you didn't give Galileo credit because they were contemporaries.
I think 2 years
So
ago.
you never think that people in
He
your
didn't
own
think it was
era
too
are
close to
famous, right?
Yeah,
Right.
that's another
That's a good idea.
Featherheads.
Or he just really didn't get along with them.
I hid the image, but whenever you're ready, I can turn it back
See you
on.
tomorrow night.
Okay, so the weather's looking good.
So
You're bringing your scope.
you have it synchronized to a certain time
Wow.
of day.
Oh, I'd like to see that.
I'm going to have her.
You got 4 hands, right? You can carry it.
No, she's going to write.
Oh,
I'm just going to watch.
you need like an engine hoist for that thing.
We've been working on it.
I never got a pie.
There's pie.
Is it a cake or a pie?
Cake. They might have pie there too. Maybe we should get
Yeah, so
get
what
the
is
barbecue.
We checked the windows.
Try to meet you there. We don't need to go there anyway.
West side barbecue and cakes.
West side.
West side.
Is it in
It's really close to the main road that goes through there.
Okay.
On the way to Georgia. We got off the highway just to rest stop, and there it was. West side barbecue and cakes. If it's even still open, I haven't been through there in a couple years.
Get everybody ready and then I'll check it out.
Do you want to do that first and then switch over to the PowerPoint, or do you want to
No, I didn't. What you
speak a little bit?
I want to do the film first. I'll switch over to PowerPoint.
No,
It wasn't. I took down a tree today. I sit down right now and fall asleep. They're good. We got more to cut down. The lifting sketch.
You all right today? I'm Jeremy.
But I would have liked to have seen it.
It's been a couple of years. Yeah. Back going here. Doing all right. How about you? Staying busy? What do you do? Well, professionally in real estate. Buying some. How about you? I'm retired. Excellent.
Now you can relax.
Yeah.
That's Jeff's.
It's good to see you. Thank you. Bill, right? Bill. Things going.
One last. 3 more.
Pull this off. This whole thing is like a giant experiment.
He's the one that wanders around.
We get everybody settled down. All right, sound check.
I'm going to evaluate that for my...
Yeah, okay.
Did you hear me all right? Okay. Like in everybody's attention, we'll go ahead and kick off the second part of the program. And then we will try to wrap up here. Now, we have a planetarium.
Did I just steal your seat?
We've got a few other resources.
No.
This whole thing has been kind of unfolding for several months, you know. Can we get back to in-person meetings? Can we not get back to in-person meetings? Where can we meet? CDU hasn't been too welcoming where we used to meet. So we've been kind of exploring this venue, going back and forth a little bit. Long story short, we get to this date, and then they have what's called a planetarium projector I highly recommend it if you can get one in your house. Not in my budget yet. So we were going to use it, and then about a week ago they said, no, you can't use it because, you know, you have to, for whatever reason. We come here tonight thinking only PowerPoint, and then at the last minute they tell us, no, it's okay, you can use it. So this whole thing is like a giant experiment. It's just kind of unfolding. So, you know, you're kind of seeing how the sausage is made, right? Sometimes it's good, sometimes it's bad, sometimes it's messy, sometimes it's clean. But anyway, here goes. We got to get our money's worth, which is basically free. So we're going to experiment with the dome projector to kind of set up the second half of the program. So Richard, go ahead and take it away.
Sure.
Now again, I apologize for our Zoom audience and our virtual audience, because you're not going to be able to see this. And this, of course, is where the benefit is of actually being here live and in person. But tomorrow night, we've got an observing session at Burton Sugar Farm. That's our dark sky site. And again, if you're ambitious and bold and a little crazy, you can go for all 110 deep sky objects in the Messier catalog in one setting, or you can kind of work through it gradually, which is what I do. But anyway, you're kind of seeing, again, a simulation of the night sky. And imagine you're looking due south. So if we're at Burton Sugar Farm tomorrow night, to kind of orient you, straight ahead, you're looking due south, that's toward the trees. Now, that doesn't help you because there's trees everywhere. But if we're meeting at the cabin, to your right is where the cabin would be set up. To your left is the cornfield. This is the trail where all the cars come in, and then this is kind of where we set up, you know, for our observing. And then you're looking due south. Now, this is shortly after dusk. Well, no, it isn't shortly after dusk. We're fast forwarding in time to roughly 2 o'clock in the morning. All right, so this is actually 2 a.m. Sunday morning. You've been out for about 5 hours. You're trying to knock out the entire Messier catalog. You've bagged maybe 40 or 50 of them. You're dead tired, you're cranky, you're in a bad mood, and now you got to go through the Virgo cluster. So that's where we are. All right, so let's orient you here. You're looking at the constellation Leo right here. This, of course, is Leo, the crouching lion. So this would be his mane, and these would be the haunches or the legs of Leo. Of course, if you look straight up, you can see the Big Dipper.
Hey, you want a picture of that, Jeremy?
Sure, why not?
All right.
We got a new toy. So there's Leo.
Oh, yeah.
Now you can actually see the lines in the constellation Leo. And we can go a step further. We can show pictures of what these things look like. So there it is. That's a lion. Leo the lion. So there you go. That's what it looks like. And again, straight up, you're looking at Ursa Major, the Big Dipper. There's Dubé, and these are all the other stars. There it is, Big Dipper. And that's actually the tail of Ursa Major, which is the Great Bear. You can see his feet right here. There's one of his feet, there's one of his paws, and that's actually what it looks like. Pretty cool, huh? Again, I recommend this. If it's in your budget, get this in your living room. I would gladly stop over. All right, so there's the Big Dipper. Right below it is Leo. So what we're going to do is we're going to concentrate on this area of the sky right here. Now there's a constellation right off of the tail of Leo the Lion called Virgo. Richard's going to bring it up right now. When you draw the lines in Virgo, it kind of looks like a big wine glass. Virgo is, that's not the Virgin, is it? You can edit this part out. Anyway, I don't know what Virgo is, but it's a queen or it's something. And again, those are the constellation lines, and there it is. That's actually the constellation Virgo. Now, this is a very rich part of the sky if you're into galaxies. And spring, historically, has always been galaxy season. So, and that's what we're talking about tonight. Turns out there's thousands of galaxies in the Virgo cluster. Again, this little area of the sky right here, off of the tail of Leo the Lion, this is Denebola, the star. Over here is the star Venedimatrix, which is at the tip of Leo. I'm sorry, the tip of Virgo. And then the constellation Virgo kind of arcs around here. Up here you've got the Coma cluster of galaxies. And down here you've got the Virgo cluster. There's thousands and thousands of galaxies. And again, a galaxy is like our Milky Way. It consists of hundreds of billions, as many as 1 trillion stars, like our sun. These are separate island universes. They're absolutely enormous. Just mind-boggling how large galaxies are. If you were to take the sun, our sun, and scale it down in size to the period at the end of a sentence in a book that you're reading, our Milky Way galaxy would be comparable in size to the continental United States. is phenomenally large. I mean, there are thousands of them, again, in this area of the sky. So that's what we're going to focus on tonight. But just to kind of orient you again, look for the Big Dipper, the paws of the bear. Below it, you've got Leo the lion, the mane right here, and the crouching part of the line. Again, you're looking due south. And then off of this star right here is where our journey into the Virgo cluster is going to commence tonight. So that's it. And I'm going to go ahead and ask Richard to turn the lights back on, get us back into PowerPoint presentation mode, and I'll go ahead and take you through this. Now, I gave this presentation about 4 years ago. This is something that's been ongoing. So this is kind of Rev 2.0 of this talk. And again, you think of the iPhone or any piece of technology that you are very fond of. What do? They don't get it perfect the first time. They just get it good enough, release it, you get used to it, and then they make some upgrades. So you got 2.0, 3.0, et cetera, et cetera. So this is basically the Virgo cluster Rev 2.0 for me, off of the talk I gave about 4 years ago or so. And I've been working on this. So I'm actually going to kind of show you how I go through this and hopefully enlighten you as to some of the techniques that I use for getting through the Virgo cluster and more or less help you. Again, you've got to do this if you want to get all 110 of the Messier objects, whether you do it in one night if you're crazy, or you do it over the course of several months if you want to do it at a more reasonable pace. So anyway, here we go. So this is kind of a snapshot. Again, every faint fuzzy you see is a distant island universe, a galaxy, as big or larger than a Milky Way galaxy. I will kind of enlighten you as to the details of this image. We'll come back to this as we go. But to kind of get started here, what is the Virgo cluster? Again, our Milky Way and Andromeda Galaxy are two of about 54 galaxies that make up the local group of galaxies. It turns out that nothing in the universe likes to travel alone. Now, our sun is a little bit of an aberration because it doesn't have a companion star. Most of the stars in our galaxy are either binary or triplet or multi-star pairs. So galaxies are kind of the same way. So we have our Milky Way galaxy here, and of course that contains our sun, the solar system, and roughly 200 billion stars. And then a good analog is the Andromeda galaxy, roughly 2 million light years away. And then you got a bunch of smaller galaxies that make up the local group of galaxies, about 54 galaxies. Again, Andromeda and the Milky Way being the celebrities of the local group. But you're basically looking at a chunk of the sky, or the chunk of the universe, that's 10 million light years across. So at the speed of light, it would take you 10 million years to get from here to here. Again, at the speed of light, I could orbit the Earth 7.5 times in a second. And yet it takes you 10 million years to get from one end of a local group to the other. So that's just one chunk, if you will, of the arrangement of galaxies. They tend to cluster in groups, and then they also tend to cluster in larger superclusters. So our local group of galaxies is part of a larger supercluster called the Virgo supercluster. And this contains the local group, again, which has our Milky Way and Andromeda, the Virgo cluster, which we're going to talk about tonight, and then M81 and M101 are actually outside of our local group of galaxies. And of course, you can find these off of Ursa Major as well. This is the Pinwheel Galaxy, M101. M81 is Bode's galaxy. So they're actually about here and right there, and our local group would be located right about there. Again, you have another galaxy cluster here. The Fornax cluster is down here. And then this giant conglomeration is essentially the Virgo cluster, containing thousands of galaxies. And again, you're looking at a chunk of sky roughly 110 million light years across. And this supercluster is one of approximately 10 million superclusters in the observable universe. So galaxies like to, clump together gravitationally into groups, and then they travel in clusters, and clusters travel in superclusters, and you have superclusters, and eventually walls, filaments, and voids. That's more or less how matter is distributed on large scales in the universe. So when we're looking into the Virgo cluster, we're looking into a separate galaxy cluster outside of our local group. Okay. Again, 110 deep sky objects in the Messier catalog. This is how you learn the night sky. If you want to become a competent backyard amateur astronomer, go through the Messier catalog. You go through this, you really learn where things are. And again, this is why I'm not a big fan initially of computerized telescopes. I think you should get a Dobsonian, it's manual, and because you learn the sky. This is, you go through these objects, and you really become familiar with them. And you always have a handful of them, if you will, that you can use at the spur of the moment for outreach. So, and again, Charles Messier lived around the time of George Washington. He cataloged these in an effort to find comets. He found a bunch of other things that we now call deep sky objects. You know, they supernova remnants like M1, a lot of globulars, planetary nebula like M57, and then you got a lot of galaxies also. And it turns out that there are 16 objects in Messier's catalog that are part of the Virgo Cluster. So that's basically what we're going to go through tonight. Now, if you subscribe to Sky and Telescope magazine, this presentation was essentially inspired by an article written in the April 2016 edition of Sky and Telescope, so I would recommend checking that out if you want to get into more details. So here we go. Again, if you look at the constellation map, we showed this earlier. Here again is Leo, Venabola, right off the tip of the crouching lion. Here you've got the constellation Virgo, then the Demetrix, and then these are where we're going to be concentrating tonight. So let's zoom in. This is the chart that I use off of my Sky and Telescope Pocket Atlas, which is not really a pocket atlas, a little bit larger than that. But here's Venabola, and here's kind of how we start. If I draw a line from Venabola, I'm going to run into a star called 6Com. Now, 6Com is a good analogy for what our sun would look like at the standard distance of 32.6 light years, 10 parsecs from Earth. This is how we measure absolute magnitudes of stars. Our sun is very bright to us here on Earth, but if you were to put it at standard distance of 10 parsecs, it would be very dim. In fact, this star is barely visible to the naked eye. If you're at Burton Sugar Farm and you're dark adapted and you have good seeing conditions, you should be able to spot this star naked eye. But you got to stare at it for a minute. So you can't just necessarily spot it. It's not one of the brighter stars. It's a little over magnitude 5, so it's very dim. But you can find it. And if you can find it naked eye, you can easily point your telescope there. And notice what we do. If we draw arrows off of 6Com, we can kind of move our way into the Virgo cluster. And in fact, we can find 3 of them right away. So here you can see 6Com down here. It's very easy from 6Com to find the edge-on spiral galaxy, M98. And then I can move to find the face-on spiral galaxy, M99. And I can easily star hop my way up to M100. So let's do it. So here again is a clip, if you will, through my 10-inch Dobsonian telescope. This is a night vision eyepiece, courtesy of Brian Hancock, you just heard from. So this is 6Com right here. I'm going to move my telescope by hand, and there you can see it, the edge-on spiral galaxy M98. So that's our first Messier galaxy in the Virgo cluster. Bright nucleus, and then you can see the disk. That's what galaxies look like. They don't break out into individual stars, but you can kind of see more or less what looks like a fuzzy patch, and that's the clue that you're looking at a galaxy. So we just got one. Now if I move in the opposite direction, and again, so there you can see M99, face-on spiral galaxy, looks different than a star. Stars are, more crisp and pinpoint. Galaxies are fuzzy patches, but that is the face-on spiral galaxy, M99. I go up to 6Com, and again, star hop my way around along these bright stars. I will find M100, and there it is. Now, M100 is one of the brighter galaxies in the Virgo cluster. You'll know it when you see it. It just bursts in the eyepiece. Fairly easy to spot. You can actually see another smaller galaxy right there. It's not a Messier, it's an NGC galaxy. But that's it. So now I've just bagged, if you will, 3 of them. So I've got M98, M99, M100. Pretty good start. So, let's go back to our chart here. Now, previous version of this talk, I would star hop my way from 6Com to get into the heart of the Virgo cluster. That's a little too complicated. You can easily lose your way, especially at 2 o'clock in the morning. You've been up for 5 hours and you're in a bad mood. So let's try and simplify this. All right, so let's get rid of this. Well, actually, we're not going to go in that direction. Let's go up and get M85 first. All right, so I'm at M100. I've got one up here. This one's a little challenging, but I've got some brighter stars, if you will, that I can star hop my way up to. And this forms more or less a diamond-shaped pattern. In fact, that's what we call it, the diamond. But again, I'm looking for another star, 11Com, that's about the same magnitude as 6Com. And you've got another one, 24, over here. These two stars, again, barely visible to the naked eye, but you can spot them if you're dark adapted and you're at Burton Sugar. You know, you're in a good dark sky location and you're dark adapted. You should be able to spot these naked eye. Now, if I draw a line between those two stars, just shy of midpoint, I should be able to more or less guess or point my telescope to this location and find M85. Now, the one thing about M85 is it's right next door to another galaxy. So I know that I found that galaxy when I see 2 in the eyepiece. So, go back here a minute. So here again, M85 is not a spiral. It's an elliptical galaxy, so it's going to be a bright fuzzy patch. NGC 4394, its companion, is a barred spiral. Now you won't see necessarily this level of structure, but you'll see 2 fuzzy patches in your eyepiece. The dimmer one is the NGC object, and the brighter one is the Messier. Messiers tend to be brighter than NGC, New General Catalog Galaxies. So that is a clue, if you will. I see this pattern in the eyepiece of my telescope that I have found M85. So again, it takes a little bit of work to star hop your way up, but if you find these 2 bright stars naked eye and roughly bisect the line between them, that's how you find M85. So that's number 4. Now, let's go back to our chart here. Again, in the past version of this talk, I would have told you to star hop your way from 6Com to get to the heart of the Virgo cluster. We're not going to do that. Turns out I found a little easier way to get there. You got 2 bright stars, very easily visible with the naked eye. Denebola at the tip of Leo, Venedimatrix at the edge of Virgo. So if I draw a line between those stars, and I go roughly midpoint between that line, I'm going to come up to the heart of the Virgo cluster. So I literally can just point my telescope there and look for a very distinct pattern, and here it is. I call it the face, and again, it's made of galaxies, but you got 2 bright lenticular galaxies here. M84, M86, which is a little brighter. You got another galaxy that forms the nose. NGC 4388 forms the mouth, and you even got an eyebrow if you like it. And here's the beginning of Markarian's chain. In fact, these 2 NGC galaxies are literally called the eyes. It's a little confusing because I like to think of these as the eyes of the face. But anyway, that's how I pick up the next 2 Messiers. So, again, roughly between Venedimatrix and Denebola, I've now bagged my next 2, which is M84 and M86, 2 bright lenticular galaxies. Now, go back to the face, and I can move my telescope down to the southwest and find the bright galaxy M87. So let me zoom out here a minute. Here's another image, again, my face, and if I move in this direction, I can find a bright galaxy, and this is one of the brightest galaxies in the Virgo cluster, M87. Now, what's significant about M87? You follow the news roughly 3 years ago, you'll realize that this galaxy was the one where the first ever black hole was imaged. Supermassive black hole at the center of a galaxy. Imagine a telescope, basically a network of telescopes the size of the Earth, using various techniques for imaging this black hole. It's just an amazing accomplishment. Roughly a century after Albert Einstein's general theory of relativity that we're now actually able to see tangible and empirical proof that black holes exist. That's the significance of M87. It's just a massive galaxy in the heart of the Virgo cluster. So again, there's my 10-inch Dobsonian, night vision eyepiece. I'm looking at the face, M84 here, M86 here, NGC 4388. That's the face structure. That's kind of where I move. And you can see the eyebrow right up there. So if I move my telescope to the southwest, you'll start to see M87 come into view. And again, I'm just moving it by hand here with my Dobsonian. It doesn't slew with a computer or anything like that. You can see the eyes over here. This is part of Markarian's chain. Talk more about that in a second. But notice, if I move my telescope down, I don't have to go very far, and M87 will now come into view. Almost looks like a globular through the night vision eyepiece. But that is a very bright and large lenticular galaxy. About 1 trillion stars. Our Milky Way has about 200 to 300 globular clusters in its halo. You know, we're very fond of these, especially in the summer skies. This galaxy here has about 10,000 globular clusters in it. So just a massive and very powerful radio galaxy. So that is M87. And it's really a thrill to see this one through the eyepiece of the telescope. So there it is. We just bagged M87, so we're getting about halfway through now. And not terribly difficult yet. All right, so let's move on. Again, there we are. We bagged M84, M86 at the heart of the Virgo cluster, and now M87. Now, where do we go from here? Again, I always go back to my face structure, and I'm going to sweep up this path of galaxies known as Markarian's chain, and I'm going to get to the edge-on spiral galaxy, M88. So that's my next task. A little more difficult. Definitely takes some practice, a little bit of trial and error, a little bit of frustration. But let's go ahead and zoom in here. Again, I got my face structure down here with M86, M84, which I showed you earlier. So let's just go ahead and kind of zoom in here and show you how that works. I sweep my way up Markarian's chain and look for M88. Now, and again, I'll show it here on the chart. I'm zooming in on this part of the chart. You see a lot of little fuzzy blobs here. Each one of these ovals is a galaxy. So getting to M88 is a little bit of a challenge. The good news is it has a very distinct pattern in the eyepiece of the telescope that kind of tells me that I found it. I'll see an oval pattern, a bright nucleus. You can see a little bit. You won't see, obviously, this level of detail. But I'll look for 2 stars off of the disk on one side and then a bright star on the other side. Once I see that pattern, I know that I've bagged M88. I'll show you that in a second. Now, for an M88, it's a challenge, but you can sweep your way around the basically the circuit here to pick up another 3 of the Messiers. I can grab M91, another face-on spiral, M90, another edge-on spiral, and it looks a little bit like this. You know, again, it's just kind of a bright oval patch, fuzzy. The nucleus of the galaxies are what really stand out. And I can grab M89, and I should be able to sweep my way back around to M87. So let's take a look. All right, again, my phase structure here, M84, M86, NGC 4388. If I go down here, again, I'll be able to get M87. Show you that again just for kind of a memory refresher. And again, I'm looking through a 10-inch Dobsonian, a very basic telescope. I like my 20-inch for galaxies. If it's properly collimated, it really is great to use for something like this. But 10-inch works just fine as well. So again, I'm just moving my telescope by hand to get to these galaxies. So I'm going to go down here, and I'm going to show you M87 again. There it is. So again, that's M87 at the heart of the Virgo cluster, just as kind of a memory refresher. And then I move back up to the face, which is where M84 and M86 are. Again, I'm doing this all by hand. Night vision eyepiece connected to a 10-inch Dobsonian telescope. So So I'm right back to my face. That's where I start, right? If I want to bag Messiers, I go here because this is a pretty easy pattern to find out. Now I'm going to move up Markarian's chain. And again, when I shot this video, it's early in the morning. I'm tired. I'm not doing a very good job of tracking Markarian's chain. But this is a very recognizable NGC galaxy next to these two bright stars here. That's an NGC. I forget the name of it now. I can look on the chart here in just a second. But this tells me I'm close now to M88. So if I move the eyepiece up, actually moving it to the left a little bit, again, you got to figure out where it's oriented in the sky. That's an NGC galaxy right there. These are two bright stars. I know it's kind of hard to distinguish. But notice, here comes M88 right there. Again, edge-on spiral galaxy, bright nuclear core, one star there, two stars right there. So when I see this pattern, two stars off the disk on one edge, the other one off the other side, I know that I've bagged M88. So that's another Messier right there. Now, M91 should be over here. I don't know where I'm going. Again, 2 o'clock in the morning, you're tired, you're groggy, you're in a bad mood. Where am I going? Okay, so I'm just moving my telescope along. I took the audio out of this clip. It's a good thing, too, because I probably used some choice words. There's another NGC galaxy. When I move my way down, there it is. That's M90 right there. That's an edge-on spiral galaxy, so that's M90. Actually, that's M90. I lied. That's M90 right there. So that is M90. So I just showed you M88 and M90. So again, M88, M91, M90, M89. You should be able to get those all in that circuit right there. So going back to this picture I showed you earlier, we just swept up Markarian's chain. That galaxy that I showed you between those two stars, it's NGC 4459. A little fainter, but that tells me that I'm close to M88. There it is, edge-on spiral galaxy. And I should be able to sweep my way around and get M91. I didn't show you that in the last clip. But there was M90. You just saw it at the very end of the clip I just showed you. Back around, again, edge-on spiral, face-on, barred spiral, and that's a lenticular galaxy right there. So that's how I get those. All right, now from M89 it gets more challenging. The first half of the Virgo cluster is pretty easy, quite frankly. The second half is difficult. So this is where it really takes a lot of practice, some time, some trial and error. But we're going to go for M58 next. So notice what I did here. Swept up Markarian's chain, got M88, swept around, got 91, 90, 89. Now I'm going to attempt to get M80, M58. So again, I'm just going to move my telescope down and kind of star hop my way into that vicinity. And more or less hone in on M58. Now you notice you got a star right next to that galaxy right there. If I can identify that star next to the galaxy, that's a clue that I found it. And again, you're looking at a face-on barred spiral. Binoculars may not be a bad target. This is where your friend who has binoculars that can show you a wide view of Markarian's chain can really help you orient yourself through the Virgo cluster. So binocular observations of M58 can also be hampered by nearby field stars edging 8th magnitude HD 109771 just outside your field of view may help. Look for an oval condensation about 8 arc minutes east of the star. So there's the HD star, and there is M58. You should be able to find it. And again, you'll notice that pattern. So bang, I've got that one. That's the face-on barred spiral. Now, one thing about Messiers, again, you got NGCs and Messiers all mixed in a Virgo cluster. Messiers are brighter, right? So one thing you've got going for you, the Messiers should be the brighter objects in the Virgo cluster. So if it looks too faint to be true, then it usually is, and you probably got the wrong galaxy. All right, so M58, M59, and M60 are all in a line. And if I found M58, then I should be able to find the other two. So let's zoom in on this chunk of the sky, if you will. So I'm zooming in right here to try and find the other two. There's M58, There's the HD star that we were just talking about. So I should be able to move in a line now, pick up 59 and 60. 59 is tough. This may be one of the tougher ones, if not the toughest one in the Virgo cluster. And of course, you see these two stars down here, Rho Virginis, 27 Virginis. That's these two stars right here. Come back to that in just a minute. But you should be able to move linearly from M58 to spot M59, and then you should be able to find M60. Now M60, again, you've got two for the price of one. I've got a bright elliptical Messier next to a face-on spiral, NGC 4647. In fact, these two galaxies are gravitationally interacting, and this is part of the ARC catalog. So you heard the presentation last month from Gary M. This is 116 in Halton ARC's catalog of peculiar galaxies. And in fact, he described it as an elliptical close to and perturbing a spiral. So when you see this pattern in your eyepiece, more or less you know, again, that you've bagged M60. And if you think you've missed 58, you should be able to find 59. If you can find 58 and you can find 60, then you should be able to find 59 midway between. So there we go. A little bit of a challenge, but we should be able to pick those two up as well. So now I'm down to 2. And the last two are, again, pretty challenging, but certainly doable. So let's go back to our chart. Now, similar to what I did with Denebola and Venedimatrix, I can also draw a line between Venedimatrix and this star right here off the edge of Virgo. And I should be able to find, again, this is naked eye visible, these two stars right here, Rho Virginis and 27 Virginis. And from there, I should be able to work my way down to find 49. Now, zooming out, again, here's Venedimatrix. There was 59, 58, and 60, which we just found. Here's the star right there. So if I draw a line from there, I should be able to work my way down to find 49. So let's do it. So if I go down, this is a little challenging, but I should be able to star hop my way down and find this star right here. I don't know the name. But if I keep going, I should be able to find this pattern right here. 2 stars in a galaxy sandwiched in between these stars. That's NGC 4526. Now that's an interesting galaxy also. It's not a Messier, but this is another famous image in astronomy. You're looking at a very large and dusty edge-on spiral galaxy that was actually host to a supernova in 1994. This is a Type 1a supernova, exploding white dwarf. Now, if you study cosmology at all, you'll know that the universe was discovered about 25 years ago to be accelerating in its rate of expansion. Astronomers and cosmologists can now use Type 1a supernova to measure the expansion rate and the expansion history of the universe because they're very good standard candles. So this galaxy, NGC 4526, was host to one of those events. So if you find that one, that's kind of interesting in and of itself. But more importantly, it's a clue that you're very close to the 15th and second to last Messier in your journey. Now, the nice thing about M49 is it's a very bright galaxy. This is another one that was a little challenging to find at first, but once I found it in the eyepiece of my telescope, it was like, okay, that's it. There it is. Bright fuzzy patch. Again, this is an older galaxy. These types of galaxies don't have any kind of spiral pattern like our Milky Way. They're older, more evolved stars, have very little gas, if any, what we call old, red, and dead. Basically, they consist of stars that have moved off of main sequence. They're not really forming any new stars. They're just kind of dead galaxies. So that's M49. So it's a little bit of a challenge, but again, you'll know it when you find it. And you've got a couple of brighter stars around there to kind of orient you that you've actually found that galaxy. So now we're down to the last one, M61. And this may be the most challenging galaxy in the Virgo cluster, the most challenging Messier galaxy. So I've got to move down really into the heart of Virgo. I zoom out again, and to find that one, I do something a little different. You can find these two stars right here, and this one is more or less a double star. I should be able to draw an isosceles triangle up to M61. That's kind of what I do. Again, I don't do a lot of detailed star hopping or anything. I'm sure there's a more refined technique, if you will, come back to version 3.0, right? But that's more or less kind of how I find it. It's the apex of an isosceles triangle. And this one also is a face-on spiral, pretty dim, but being a Messier, you will know it when you find it. And this was also a galaxy that was host to a supernova not long ago, in fact, 2020. And this was a Type 2 core collapse supernova. You know, you probably won't see it, but you'll know that you have spotted that Messier more or less when you find it there. So that's it. That's M61. That's all 16 Messiers in the Virgo cluster. Now, there's more than one way to skin a cat, right? There's several different techniques for going about this. And here's some other sources to consult, if you will. Again, check out this article in the April 2016 edition of Sky and Telescope magazine if you'd like to learn more. There's a write-up on this at this link right here. And Robert Garfinkel goes through some more detailed star hopping, not only off of 6Com, but also off of Venadimatrix to get 58, 89, 90. So again, there's more than one way to do this. But that essentially is a quick look at how to bag these 16 Messier galaxies in the Virgo cluster. So that's it. That's my talk. Anybody have any questions, comments? Or as one of my college professors would say, cussing or discussing? Yes, Steve.
With that night vision, would you say that's pretty much what it's like looking through the eyepiece regularly?
The eyepiece enhances some of the features. So, I mean, you saw some of the distortion with the eye. If you turn the gain up on the eyepiece, it's going to be brighter, and you're going to see more noise in the background of your image. So it definitely is enhanced a little bit. What the night vision will do, though, depending on what object you're looking at, is it can bring out structure. I mean, we had it on the Crab Nebula. You could see some of the structure in the actual nebula, some of the lines that look like an actual exploding star. I think I was trying to think of some of the other objects we looked at with the night vision. But you can see more detail in some of these objects. But what I showed you earlier is more or less what it would look like without the night vision. I mean, the night vision enhances it, but if you were just looking through a regular, you know, low power, wide field view eyepiece, 25 millimeters or 31 millimeter Nagler would be a great eyepiece to use for this. You'll see more or less what you just saw there. So, I don't know, Brian, if you have any other comments you want to add. We've had a lot of fun with the night vision over the years. It's better in my 20-inch than in my 10-inch because you can gather more light. So, yeah. Anybody else? Okay, so with that, do we have anything online? Nothing? How are we doing here on time?
10 o'clock.
10:01. That's timing right there. I wanted to finish this meeting at 10 o'clock, and it's 10:01, so we're only 1 minute over. So that's it.
The only comment I got online was, great job.
Okay. Thank you very much. Again, I want to say thank you to Richard and Dave for allowing us to come out and meet. Good to see everybody again. Everybody stayed awake. I don't know what we're going to do next month. Tomorrow night, again, we got two things going. We got observing at Burton Sugar Farm, so you can go through this entire thing. There will be a test. If you don't pass, don't come back. We don't want you. No, if you want to come out tomorrow night to Burton's, it looks like it's going to be favorable. We'll give the no-go notice. And we're also going to be at, where else are we going to be?
Pinecrest.
Pinecrest, yes, Pinecrest. So if you want to bring your telescope out there, you can do that as well. We've got a busy month coming up. We'll send notices out soon. And
don't
thanks again
forget
for coming out,
MoSH
guys. Yes?
In a week. MoSH in a week.
What's that? Oh, yes. Yeah. The 8th, which is next Friday, correct? We're going to have observing right here on the front lawn of the MoSH. So if you can bring your telescope out for that, come on out and help us out, help the MoSH out, and who knows, maybe we'll score this venue next month. So that's it. Again, table around back, sign up if you haven't already, feel free to take whatever. And with that, we'll turn the lights on and wrap up. Thanks again, everyone, for coming out.